Right, I do welcome you to today's conversation in managerial economics, where we are trying to go through the paper that we had in 2024, that's 2024 exam, and the presented for us is question number one. And so question number one is reading that as a manager of a firm operating in the Zambian energy sector, you have been, keenly following developments within the electricity subsector. Now, the key stakeholders in this sector include ZESCO, ERB, the Ministry of Energy, independent power producers like your firm, for example, which actually generates electricity and sells it to ZESCO to cover, generational costs and thus earn profit. Now, recently, the ERB approved ZESCO's request to increase electricity tariffs by 10% as part of the multi-year tariff migration plan. So the Energy Regulation Board approved the proposal from ZESCO to increase the electricity tariffs. And so the question number one is saying, 1A, in efficiently managing your firm, explain the principal agent problem and propose how you would mitigate. So can you explain the principal, can you explain the principal agent problem and do propose how you would mitigate it? So the first thing to begin with is to understand what it means or what we mean when we say principal problem. Now, principal agent problem arises when there is a conflict of interest, between the firm's owners. Those are called the principals, okay? The owners of the firm, they are called the principals, right? And with the managers that you call the agents. The managers are usually called the agents. So you have the owners of the firm and the agents. So now there is the conflict of interest between the two. The managers of the firm, who are the agents, and the owners of the firm, who are the principals themselves. So in this case, what we find is that the managers may not always act in the best interest of the owners, especially if their goals, the goals of the managers, e.g., let's say, personal bonuses, job security, differ from those of the owners. Usually the goals of the owners, who are the principals, will be profit maximization, right? The owners would want to have the profit maximization. So now, if you see that these interests are not what, they are not well looked into, or they are conflicting, then you will have what we call principal agent problem in the firm management. So now the question is, how do you mitigate? That is the other part of the question. We have already explained what it is. So number one is to introduce the incentive alignment program. Incentive alignment. What do we mean by incentive alignment? This is where you offer performance-based compensations, right? You offer performance-based compensations like the bonuses, the stock options, to align managers' incentives with the goals of the firm. Do you get that one? That the firms, that the interests or the goals of the managers can be properly aligned, they can be properly aligned with what? You need to make sure that you align these with they are properly aligned with actually the major goals of the firm. So what you can do, you can produce things like bonuses. Then people that have worked better, they are given some bonuses. People are forced to work harder, and in that way, you see that even the firm is also, it's actually benefiting. That is from that. Then you can also introduce what is known as monitoring reporting. Monitoring monitoring and reporting, for example. This is another point. Monitoring and reporting. This is where you implement regular performance reviews, right? Regular performance reviews are implemented. So you require managers to provide transparent reports on operations and financial metrics, right? They have to give you reports. They have to give you the performance. They have to explain how the performance is of the firm, giving you reports in short. Then there is what we call corporate governance in this case. That's one of the goals that we can actually put as well. It's called the corporate governance, right? Corporate governance. Now, what about corporate governance? How can it be used, to mitigate principal agent problem in firm management? You establish a board of directors. This is where you establish the board of directors to oversee managerial decisions and ensure they align with the shareholder interest. Okay. What you do here, this is where you introduce the board of directors, the BOD, the board of directors, so that the board of directors can oversee managerial decisions, the decisions of the managers, and ensure that those decisions are properly aligned, with the interests of the shareholders. So basically, those are some of the ways on how you can mitigate, the principal agent problem firm management. There could be many other ones, but at least 3 of them that I've given you may be enough to help you. Now, let's go to part B of the question. Part B of the question is very interesting. It says, now suppose the Energy Regulation Board grants your firm a license to directly sell electricity to consumers as indicated by an estimated residual function, and you have this function. Let me just use the red marker. You have the function here. This is the function. The function that we have is QD is equal to 12,000. Quantity demanded of good X actually is equal to 12,000 minus 3 price of good X plus 4 price of good Y minus income M plus 2A, where A is defined as, the units of advertising, and M is income. Then PY is the price of another good, which is good Y. Remember, we are looking at good X in the conversation according to this demand function. So, we need to ensure that we take into consideration how the price of the related good, in this case, the related good Y, how does it really affect the quantities demanded? So basically, that's the conversation. Now, the question is saying the amount of electricity sold, consumed sells for, 0.4 per unit, 0.44 per unit. That is, electricity, remember, in this case is X. X is our electricity. And Y, which is the related good, related to electricity, is selling at 1 kwacha per watt, per unit. And the company utilizes 200 units of advertising. So in this case, our A is equal to 2,000. And you're also told that the income is 10,000 M. Income is 10,000. So how much electricity should the consumers produce? Really? How much electricity should the consumers produce? It's just about substituting all these elements that you're seeing into the demand function. So let's go ahead and do substitute. So it will be 12,000 minus 3 times PX, price of good X. Our X is the electricity, which is 0.44 units in this case, plus 4 times the price of good Y is 1, That's what the question says. M is the income is 10,000. That's what the question is giving us, and plus 2A. And our A is the units of advertising, that is 2,000 units. And you need to do your computations from here. Just command your calculator straight. No need of suffering. Command your calculator and you shall have the units produced. Okay. So what does the calculator give you? Right? When you do your computations, let's say you have 12,000 minus 3 times 0.44 you close plus all these are minus, all of them they are negatives. Negative 3, then you 4 is plus 4 times 1, it's just 4 in this case, then plus 10,000, right? Plus 2 times 2,000 units of advertising. All that is giving you, what that is giving you is approximately hold on. Let me do my work. Let me just redo my work. 3 times 0.44. Yeah, 1.32 and minus 12. When you do the computations of all these, okay, it's negative M here, it's not plus C. M is negative, so it's minus 10,000. When you do your computations, you should be able to get 5,002.68, right? 5,002.68. This is how much units they should produce. So these are how many units they should produce. 5,002 units. 5,002 units approximately of electricity they need to produce. Okay, let's move on to another part of the question, which is part B2. It is saying, are the quantities of electricity and Y substitutes or complements? For you to know whether quantities of X and Y are substitutes or complements, right? You need to look at the response of the demand of electricity to the changes in the price of the related good, right? Do you have the answer that is negative or positive? So what you do is you got to derive the function, okay? You got to derive the function with respect to price Y now, because the good that we're looking at is good X, which is electricity. So we differentiate it with respect to price of good Y. So if you differentiate all this using your knowledge of calculus, how to differentiate the function, you know that the constants like 12 will become 0, right? All the constants become 0. Even this price of good X, since we are interested in price of good Y, this will become be treated as a constant, it becomes 0. Everything will become 0 and there is no price of good Y. And then you shall have just, QD, that is concentrating on P4 price good Y. And when you differentiate that, you have 4, positive 4, actually, that's the answer. Now, when you find that the derivative is positive 4, what that indicates is that electricity and good Y are substitute goods. Why? Because the answer is what? It is positive. What makes sense, or what you should pay attention here, is just the sign. The sign is what is more important. Is the sign positive? Is the sign negative? If the sign is positive, it means they are substitute goods. If the sign after differentiating, you find that it's negative, then that would imply they are complementary goods. That's the message we are sending. Let's go. Now, part 3 is saying, is electricity a normal good or an inferior good? For us to tell whether electricity is a normal good or an inferior good, we need to consider income, the relationship of income and the quantity demanded of electricity, or rather, let me say the influence, right? The influence of electricity on the quantity demanded, on how income, influences actually that. So that it can still be done by differentiating the function. Differentiate the function and you pay attention to the to the symbol that remains on M here where there is income. Now, everywhere where there is no income, you know from your knowledge of calculus that all those areas will be treated as constants. There will be zeros. So QD will be summarized as this, your QD, your quantity demanded or your function will be just negative M. Now you're differentiating this, you're saying dm, dq dm, but differentiating this function with respect to M, right? dq dm. So you have -1, right? You are differentiating with respect to M. So you have -1. So now, if you have -1, the answer is negative. We are just interested in the answer when you are deciding whether a good is a normal good or inferior good. You look at the sign that you get after differentiating the function, okay, with respect to income. So what that communicates to us is that since the sign is negative, this one is an inferior good. But if the sign were positive, that would have implied that this is a normal good. It would have been a normal good for us. Okay, that would have been the question, right? That's a message we are sending. It would have been a normal good, but since the sign is negative, we say this is an inferior good. It's an inferior good. Let's move on. Now we go to part C of the question. It says, can you discuss the 3 sources of rivalry and that exist in economic transactions? Which of these 3 sources is typically absent in most electricity markets, right? Let's go and discuss the 3 sources of rivalry, right? Now, the main sources of rivalry in economic transactions and their absence in electricity markets would include the following, right? They would include the following. Actually, we can break them down into the types. Number 1, there is what we call, price rivalry. Price rivalry, right? Price rivalry. What about price rivalry? This is where now the firms are competing, okay, by lowering their prices to attract more customers. So competing firms here may lower prices to attract more customers under price rivalry. You'll see that rivalry, it's competition, right? Then the other source of rivalry would be product differentiation. Product differentiation. Yeah. Now, product differentiation, this is when the firm, is trying to distinguish their products to attract specific customer segments. So they're trying to distinguish their products so that they can attract specific customer segments. Yeah, that's what they're trying to do. So you find all that competition. The other source of rivalry can come from innovation, right? Innovation competition. Now, this is where the firms invest in new technologies to gain a competitive advantage. So the firms are, investing in new technologies so that they can gain competitive advantage. Those are the 3 major sources of rivalry, that we are talking about. Now, the question is also asking us about the absence of them in this market, the electricity market. What you should understand is that in most of electricity markets, price rivalry is typically absent due to the natural monopoly characteristics of electricity supply. High infrastructure costs and the regular constraints often, they limit that, resulting in a single or limited number of suppliers that you can find under this. So you don't have such kind of rivalry. There is no such competition because there are very few firms usually, under this market, electricity. Usually it's maybe one or two of them, or maybe three. You may not really have a lot of them supplying electricity. That's why you have the absence. Now, we can move to question D. 1D. Why should ZESCO obtain approval from the ERB to increase the electricity tariffs? Why do you think the ZESCO guys need to do that? Now, what you should understand is that ZESCO, as a regulated utility, must seek approval from ERB, the Energy Regulatory Board, to raise the tariffs to ensure that price changes are justified and fair to customers, right? The reason is to ensure, right? Ensuring that the price changes that the ZESCO guys are proposing, are justified and fair to customers. Now, this regulatory oversight prevents price exploitation, and actually it ensures that tariffs adjustments align with public policy objectives. For example, like affordability and access, affordability and access. So those are some of the reasons as to why ZESCO has to obtain approval. ZESCO can't just do things minus the knowledge of the Energy Regulatory Board, ERB. Let's go to question number 8. Now, this one is saying, what role does the Ministry of Energy as a policy-making institution play in the operations of the firm in the market of electricity? Really, what is the role? Why do we need the Ministry of Energy as a policy-making institution? What does it do, right? What does it do in such a market for the firms that supply electricity? That's question 1. The role of the Ministry of Energy actually is to just act as a policymaker, right? They act as a policymaker, all right? They set, regulations. They set regulations and guidelines. They set regulations and what? And guidelines for the energy sector to promote sustainable and reliable energy supplies. They want to make sure they set those guidelines so that what? They set the guidelines so that, there can be promotion of sustainable and reliable energy supplies What the Ministry of Energy does is that it ensures that electricity providers, for example, ZESCO, operate within the legal and ethical standards. They have to make sure that these guys operate within the legal and actually ethical standards. So ZESCO is regulated. It doesn't just do things on their own. Actually, ZESCO does report. ZESCO reports to ZESCO does report to ERB, Energy Regulatory Board. So what this does is that they can foster fair competition and economic development, including energy security. So those are some of the roles that the Ministry of Energy play actually as a policymaker in this institution, right? They set regulations, they set guidelines so that there can be sustainable and reliable energy supplies. And again, they ensure that electricity providers, this would include ZESCO actually, including your firm, they should be there to operate with the legal and ethical standards fostering fair competition and economic development and energy security. Now we can go to question F. We can quickly move to question number F. Now, question number F is, should Zambia become an exporter of petroleum products such as petrol, diesel, and paraffin? Should Zambia become an exporter of petroleum products such as, petrol, diesel, and paraffin? How would the government regulate the international markets? That's the question. How would the government regulate the international markets? Now you have to pay attention. You see, if Zambia become an exporter of petroleum products, the government would likely regulate the international markets through the following ways. Number one, they can introduce what is called export licenses. Export what? Export license. Export licenses. This is to control the quantity and the quality of petroleum products, right? We need the licensed dealers. We need people that are licensed to work in this market. Yeah. Why should you have the licensed dealers? This is to ensure that you can put under control the quantity and the quality of products that are being exported. Number two, pricing controls. Pricing controls. Pricing controls. Pricing controls. Now, to ensure that the local consumers are not disadvantaged by excessive exports that could drive up domestic prices, there can be price controls, right? The government can regulate prices. Then trade agreements. Trade agreements is one of the ways. Trade agreements. Now, the trade agreements will be there to establish stable export relationship with importing countries and protect national, interests. They can make sure that they establish very stable export relationship with, importing countries and protecting the national interests. That's about that. Those are some of the ways: export licenses, pricing controls, and trade agreements. We can now move on and go to question number G. Let's go to question G. Yeah. Question G is saying, how would an increase in electricity tariffs affect your firm's operations within the energy sector? If the tariffs are increased, okay, let's say tariffs have been increased in electricity, of course, electricity tariffs, how do you think that would actually affect the operations of the firm, especially those that work within energy sector? Now listen carefully. We want to check the impact of increased electricity tariffs on firm operations. Now, an increase in electricity tariffs would raise operational costs. What that would do, it would actually raise the operational costs. Maybe let's try to be so particular, particular energy intensive processes. There are some of the processes that are energy intensive, they need energy. So the energy intensive processes, now the firms might experience reduced profit margins, unless they pass on these costs to consumers. So some may actually even invest in energy efficiency or alternative energy sources so as to mitigate the impact of higher tariffs. That is actually what they can do. They can want to mitigate the impact of higher tariffs. They can do all that. All right. Now, question F is question H. Question H1. H is saying, how can implementing a peak load pricing strategy maximize your firm's profits? Maybe your question is to understand, what does the peak load pricing strategy mean? Now, the benefits there. If you implement a peak load pricing strategy, this actually can help you to maximize profit by charging higher prices during a period of high demand. That's what that means. Implementing a peak load pricing strategy is when you are charging higher prices at the time when people actually are demanding the product more. Okay, there's that time when people are really desperate of a product, they really need it, and at that point you charge higher prices. So now, what are some of the advantages or the benefits? What that would do actually, what that would do is that you know you will help manage demand, and actually it will also reduce the need for expensive infrastructure expansions. It actually encourages customers to use electricity during off-peak times, balancing the load and lowering the costs. Those are advantages. You can do what? Lower costs, lower costs. You can balance the load. Actually, you can balance the load. Yeah, during that time, you can actually encourage customers, to use electricity during off-peak hours, off-peak, off-peak times. There are those off-peak times when the demand is not very high, but they can be encouraged. So this is one of the ideas, or these are some of the advantages. Let's go to question I. Question I is saying, why do you think ZESCO would implement a two-part pricing strategy? A two-part pricing strategy. Now, what is two-part pricing strategy? Right? Two-part pricing strategy includes a fixed charge. There is a fixed charge on the other side, a fixed charge and a variable charge. And what? And the variable charge. Fixed price and variable charge. Fixed, there is a fixed charge and a variable charge. It can provide ZESCO with a very stable revenue streams while incentivizing the consumers to use electricity efficiently, right? You have a fixed charge and a variable. Okay, a fixed charge and a variable. This can actually incentivize consumers to actually use electricity efficiently. Yeah. Now, this approach can actually enhance the revenue predictability and encourage, conversions, right? You can actually encourage the conservation of energy, and actually you can also predict the revenues if you are using this one, because at least there's some fixed amounts, fixed ones. We are sure that no matter what, they will all be there. Now, on J, how can ZESCO utilize a transfer pricing strategy to optimize profit? You are interested in knowing what is transfer, pricing strategy. Now, when ZESCO is using transfer pricing, strategy, they can set internal prices for electricity that is sold between different divisions. That is to ensure that each unity operates efficiently. They can set internal prices of electricity that is sold between different divisions, okay? That is to ensure that each unity operates efficiently. So by doing so, ZESCO can actually allocate costs and profits across units to reduce tax liabilities and improve overall profitability within the regulatory constraints. That is what they can do actually. So you have to make sure that they set the internal prices for electricity, especially that one which is sold to different divisions, right? If that happens, usually that would actually ensure that each unit, operates, efficient. That's what they do. Question K is very interesting. You already have an idea of this obvious from your financial management knowledge, but it is reading, due to the increased electricity tariffs, you are encouraged to expand your firms so that you can actually contemplate purchasing a more efficient electricity generator that will actually cost you 300,000, let's say, and has a useful life for 5 years. Now the machine will use the year-end cost reduction of, these are savings that we have, 50,000 in the first year, 6,000 and 75,000, 90,000 in the fourth and fifth year. Yeah. So that is that. So you buy this using 300,000 and you observe the cost by these every year cost will be reducing. What is the question requiring you to do? What is the requirement? What is the requirement? The required is, what is the net present value of the cost savings of the machine if the interest is 8%? So those cost savings, those amounts, 50,000, just to discount them. You understand? We want the present. We want the present value. Just to discount these at at 8%. There's nothing much here. Discount them at 8%. Discount them at 8%. And 90,000. Let's discount this. This is for 2 years. So at 8%, it will be 50,000 divided by 1.08 plus the other one we brought in, 60,000 divided by 1.08 to the power 2, because that's the second year, 75,000 divided by 1.08 raised to the degree 3 plus 90,000 divided by 1.08 raised to the fourth degree plus another 90,000 divided by 1.08 raised to the what? To the fifth degree. And then do your computations, right? Do your computations. Do your computations to find the next present value. Let's go and do this quickly. We hear what we have. Let's see what we have to find the present value. We just sum all these. Sum these. So 50,000 divided by 1.08, plus 60,000, 60,000, that is divided by 1.008, raised to the power 2. Okay, is equal to that plus 75,000. That should be divided by 1.08 close raised to the power 3 is equal to plus 90,000 divided by 1.08 raised to the power 4 is equal to that plus another 90,000, that is divided by 1.08 to close that, raise the order to the fifth degree, and this is what we have. So the present value of this is 289,929.62, which is actually 289,000 kwacha 926. Okay, 2,289,926 kwacha and 62 ngwe. That's the present value. That's the present value. Okay, that's the present value. Part B of the question. Part B of the question is saying, based on your calculation, calculated net present value, should you choose purchase the machine? So now we want to compare. When when you're doing the net present value, remember the net present value is found by saying net present value is basically the negative cost, the cost of the machine, plus the present value of the cash flows, which are these savings that are found. So this is the total present value that we have already found. Then we also work out the costs, which was negative 300,000, right? Negative 300,000 plus 289,926.62. Then you find that this cost is negative because that's the investment actually. Right? You're buying that's the cost of investment. So if you do your computations properly, you will have to 289 9 26.62 minus 3, right? Minus 300,000. 300,000, which is the cost of the machine. What does that give you? 300,000, the cost of the machine. That gives you a negative value, right? That gives you negative value. So it gives you negative 10,070, 10,000 negative. Now, since it's negative value, the NPV, when the net present value is negative, you don't accept the project. You reject the project, reject the what? The project. It means the benefits of buying it, they are not better than, the goods of buying. Yeah, the benefits of what? Of buying it. The benefits of what? Of buying it. That's the message that we are sending across. Reject, but if it is positive NPV, it means you accept the project. It means the benefits actually outweigh the costs. There are much more benefits, much more. Yeah, there are much more benefits in doing that. So this is the message that we are actually sending across. Let's go to question number B, which is actually the last one. Question number 32 actually of this, which is the last one. Now you need to pay attention when I'm dealing with this one. Yeah, dealing with this one. They are saying now, can you assume that ZESCO is the sole provider of electricity? Yeah, to meet the monthly demand for electricity in the country, which is given by inverse demand function. The inverse demand function is price is equal to 1,000, very big numbers, 0.5 Q. The utility company has set up 2 electric generating facilities. Yeah, and these are the Karibada, and Victoria Falls. So the cost of producing electricity at each of them is given by these functions. This one is for Kariba Dam, the other one is at Victoria Falls, right? The costs, they just look the same though. The costs just look the same. The costs look the same. Then saying, can you determine the profit maximizing amount of this? Now listen carefully. This question comes from oligopolistic market. This is the oligopoly where you oh sorry, it's monopolistic market where you have more quantities. So you need to produce things like reaction function, right? Reaction function since you have two facilities. So now, how do you actually go about this one? Actually, that's the area of interest. This is what we're interested in. You know that in the price function, the same price function that we have, in the price function that we have, we are given that you have 1000 minus 0.5 times Q. Now, this Q is both Q1 and what? Q2. So you can just write Q1 plus C, Q2, like that. That's our demand. And then the costs are actually 2. So let's go ahead and actually work out this. So this will be 1000 minus 0.5 Q1 minus 0.5 Q2. This is our new price function. Then we are saying that can you now find the revenue? Can we find now revenue at the facility 1? If you know that to find the revenue, for you to find the total revenue is found by what? Total revenue is found by setting price times quantity. This gives you revenue. So this same price that we have already found, the price is this whole function. We will multiply it by Q1. So Q1, quantity 1, right? Quantity 1. So let's now start expanding. We want to produce what we want to produce actually is the total revenue function. We need the total revenue function. Yeah, the total revenue function is very important. Yeah, so that we can find the profit maximizing outputs. Remember, output maximize at the point where marginal revenue is equal to what? Marginal cost. That's simple for the facility A and for for facility A. Now for facility 1, we want to find a point to reach at a point where marginal revenue is equal to marginal cost. That's what we are looking. So when we get at that point, the message that we're sending is that let's go and look for marginal revenue, marginal cost. How do you find marginal revenue? We cannot find marginal revenue if we haven't found total revenue. So total revenue is found by saying price times what? The price is already here. We have already found it. So times quantity 1. So we're focusing on 1 now, right? 1. Q1, that is for the facility at Karibada. So let's multiply throughout. This will be 1000 Q1 minus 0.5 Q1 squared, right? Minus 0.5 Q2. Now we've expanded that. Once you multiply with that, then we can actually now find the marginal revenue, because this is now the total revenue function. What you found in this one is now the total revenue function. The total revenue function. Now, the total revenue function that you found need to be differentiated. Use your knowledge of calculus to differentiate this. When you differentiate this function with respect to Q1, it will give you the marginal revenue. So it will be the TR over the what? The Q1. So let's differentiate this. If you do your differentiation properly, you will have 1000 minus, drop, those things, drop the power and reduce the power by 1. So it will be, this will be 1. Because 2, drop 2 and multiply it by half, it will be just 1. So this will be Q1, just like that. This one has no Q, this part has no Q1, so we are not differentiating. We just differentiate everything with respect to Q1. And when you do that, Then what you have produced now, this one, is called what? It's called the marginal revenue. It's marginal revenue for firm one, right? Marginal revenue for firm one. And similarly, this is asymmetric, then marginal revenue for firm two will just be 1,000. You do the same process. It's only that now you differentiate with respect to Q2. Yeah, with respect to Q2, you have minus Q2 like that. So these are marginal revenue. This is marginal revenue for firm one or for facility one, which is Karibadam, and marginal revenue two for facility two. If you have found the marginal revenues, it's easier now to find the output. So for firm one, we are still with firm one. Let's go. With firm one, what do we do? Right? With firm one, what do we do? For firm one, we need to set now marginal revenue equal to marginal cost. So marginal revenue shall be 1,000 minus Q1. That should be equal to marginal cost. But marginal cost of firm one, Karibada, it's derived from the total cost. There is a total cost at Karibadam, this one. That's a function of total cost. So what do you do for you to find the marginal cost? Remember, total cost, if you're given the total cost function, then you want to find the marginal revenue function. You have to differentiate this. Use your knowledge of differentiation, differentiate this function with respect to Q1. So it will be the TC, the Q1. Differentiate this with respect to Q1. This is a constant, it will be 0. Then you have 10 Q1. Simple. 10 Q1. Now you can observe that actually that's it. 10 Q1, that is the marginal cost actually for firm 1. So you can set it equal here, 10 Q1. So we want to look for the output, right? The amount at the first firm. At the first firm, we want to look for the amounts. What do you do? You want to look for the amounts. Make subject of the formula Q1. Get this negative Q1 to the other side of the equation. So it will be 11 Q1 and divide through by 11 so that we can have Q1. Q1 is equal to 1,000 divided by 11. 1,000, right, divided by 11, which shall be 90.91. So which is approximately 91. You can approximate that 91 units. Those are the amounts of electricity that should be produced. 91, units at the facility number 1, which is Karibadam. So they have to produce that. Have to produce 91, units. What about at the Victoria Falls, which is 22? It's the same process again. You need to begin by finding the marginal revenue, but you can't find marginal revenue before you can find what? Total revenue. Total revenue is price, and of course our price is given as 100, 1,000 minus 0.5 times Q. We are told that our Q is same as Q1 plus Q2. So when you FOIL, you expand your price will be equal to 1,000 minus 0.5 Q1, minus again 0.5 Q2. Now you want to find the revenue since you have this as a price with respect to Q2. So you multiply this by Q2. It will be price times Q2. So the whole lot of this will be multiplied by Q2. So you have 1,000 Q2 minus 0.5 Q1 and the Q2, minus 0.5 Q2 squared. Then you lower the function like that. Okay. You differentiate now this function with respect to Q2. It will be 1,000 here minus 0.5 Q1 minus minus what? Minus 1, because 2 dropped it down, multiplied by 0.5 is just the 1. So it will create that. This is the function. This is how it is coming out as a function. This function actually is for the reaction function. Sorry. This is the reaction function that we find. Okay? The reaction function that we find with respect to PM2, the reaction function. So now, this reaction function that we found has been already differentiated, obvious. Yes, we have differentiated this so that we can find the marginal revenue with the what's it, with the respect M1, M2. Actually, we can go ahead, we'll redo for M1, I think. We need to redo for M1. There was a mistake. Let's continue with M2 like this. Let's continue with M2 like this. So you find this reaction function when you differentiate. So we can go ahead and this marginal revenue, set it equal to marginal cost. We have already found our marginal cost for PM2, right? Where do you get it? It's here. So it's 10050 plus C5 Q2 squared. Differentiate this with respect to Q2 to the 10 Q2. That's a marginal cost. Because this is total cost. So to find marginal revenue, differentiate. So we need to set this cost equal to the, we need to set it equal. It has to be very equal to the marginal revenue function. So they have to be equated. Let's equate it so that we can see the for this term one. We need the proper reaction function. So it will be 1,000 minus 0.5 Q1. Let me slow down here. Minus Q2. Right? Equal to 10 Q2, which is the marginal cost. And when you have all that, let me slow down. We need a reaction function for with respect to PM2, or to facility 2. We can collect like terms together. Those that have got Q2, they can come to the other side. And when you collect the like terms together, you shall have when everything crosses the equal sign to the other side. Let's say this part crosses the equal sign to the other side. You have 1,000 equal to, this will become 11 Q2 now, plus 0.5 Q1. All right. This is the function that you have. This is called a reaction function with respect to what? With respect to PM2. Let's get another reaction function with respect to PM1 now. We'll repeat the same process because we need to have these two reaction functions and solve them simultaneously. We need to solve them simultaneously. So let's go ahead and have this. We'll repeat this again with PM1 and we'll have another reaction function. So with PM1 again, you're saying the price is still, or facility 1, is still 0.5. Now there are two Qs, I've already said. It will be Q1 plus Q2. When you expand, that will be 1,000 minus 0.5 Q1 minus Q 0.5 Q2. Okay, when you have all that, then to find the revenue, we'll have the total revenue. You have to multiply this by Q2. Now, Q1, sorry, we are looking at it with respect to Q1. So when you multiply this to find the revenue, total revenue, remember total revenue is price times quantity. So it will be very, very nice. So let's go ahead and have this. Let's go ahead and have this. You have 1,000 Q1 minus 0.5 Q1 squared minus 0.5 Q1 and Q2, right? Then this is total revenue. This is our total revenue function. We need to find the margin of error by differentiating this with respect to Q1. And when you do that, the differentiation, you have 1,000 minus, Q1 minus 0.5 Q2. Yeah. So this equal to 0 now. Now we have the marginal revenue function with respect to have the marginal revenue with respect to Q1. Yeah. So now to set this to make a reaction function, remember a reaction function, if you got at a point where marginal revenue is equal to marginal cost. Marginal revenue is equal to marginal cost. That is the point where 1,000 minus Q1 minus 0.5 Q2 is equal to the marginal cost. And the marginal cost, when you differentiate this total cost function for one, we've already said this will give you 10 Q1. Then from here, you can work out the like terms together, and then we need to solve the reaction function. The two reaction functions simultaneous. You will have Q1 and Q1 that will give us have all these costs equal sign the other side with 1,000 that is equal to 10 to 11 Q1 plus 0.5 Q2. Then there was another function that we had, right? The previous one now with PEM2, because we need to solve these simultaneously. That one was 1,000. So we need to keep that one was 1,011 Q2 plus 0.25 Q1. Okay. These two have to be solved simultaneously. Solve two of these equations simultaneously. How can you solve these? You can make one the subject of the formula. One of them can then you insert into the other one. Let's maybe get the first one. Take for example, make Q1 or Q2 as the subject of the formula, right? So it will be 1,000 equal to 11 Q1 plus 0.25 Q2. You want to make Q2 the subject of the formula, then you have 1,000 minus 11 Q1 equal to 0.5 Q2. Divide 2 by 0.5. Divide everywhere by 0.5. Everywhere by 0.5. We are solving this simultaneously. If you do your computations properly, you will have the function Q2 now equal to what? Everywhere divided by 0.5. If 1,000 is divided by 0.5, means that you just divide by 1000 divided by 0.5, just be 2000. Then for 11, it will be negative 22 Q1. That's good. So now, if you have Q2 like that, you can get this Q2. Since Q2 now is expressed in this form, has been made the subject of the formula. You can get it and substitute it into the next equation, second equation. It's basically just about solving the equations, nothing more or nothing little. Just to solve the spontaneous equation. Or this equation, if you don't want to use, this is the substitution method that I'm talking about. You can even use elimination method, you can use Cramer's rule method, or whatever method you want. You can solve this equation spontaneous. That's what I'm trying to tell you. But to me, I'm trying with substitution method. So let's substitute into the second equation where there is Q2, we are putting this function. So it will be 1000 equal to 11 times Q2 is the whole function. It is 2000 plus 0.5 Q2, right? Right? Is it all 0.5? Is it 0.5? Sorry, it's 22. This function is 0.2. It's not 0.5, it's 22 Q1. Yeah. Then it plus 0.5 Q1. That is same equation. So now you got to, from here, you got to solve. We are solving for Q, by the way, the output. That's what we want. Those are the notes. You can expand this. 11,000 times 2,000. That will give us 22,000. 1,000 equals to 22,000 plus 242 U1 plus 0.5, obviously. U1, you know that this will be 242.5. When you add 0.5, that's it. So this will be 242.5 U1 equal to 22,000 crossing the equal sign to the other side. Where 1,000 become a negative number. So minus 1,000 is 21,000. And since we want Q1, we can divide it by 242.5 by 242.5, right? When you do the division, so that output 1 can be equal to 21,000 divided by 242.5, which is 8 what? H1 is 86.5, approximately 87 units. That is for frame 1, 87 units. Now, if you have the Q1, this Q1 that you found now, using this way of solving, you can get it and substitute it in any of these equations and solve for Q2. Let's solve for Q2 now. Any of these equations, you can even use this one. You can say 1,000 is equal to 11 times Q1 is what? 86.5. We should be rounded off as 7 units. Plus 0.5 Q2. We want Q2. I've already found Q1. Let's solve for Q2. Output at 2, or sorry, at facility 2 to Victoria. So that will be found by saying that 11 divided by 87. 957. So it is 1000 minus 957 equal to 0.5 Q2. Divide through by 0.5. This minus 1000, giving us 43. Now, 43 divided by 0.5 both sides, since we divide by 0.5 to find Q2. Q2 will be equal to what? This times 3 will be 86. So again, 82 will still be the same amount. Will still be 86, 86.5. What that means is that why should they produce the same amount? Because they have the same cost. You understand? So they can produce the same amounts. They are producing 86 both sides because they have the same cost. They share the cost. If the costs were different, they could have actually produced different amounts. So the Q output is 86. So in conclusion about this, let me just conclude like this. The steps. When you're given a function like this, where there are the cost is partitioned. Number one, you need to look for a reaction function for each term. Now, to get a reaction function, I'm saying a reaction function is found by you saying at a point where marginal revenue is equal to marginal cost. So your duty is to look for marginal revenue. Marginal revenue is found, is derived from total revenue and share the total revenue. Those are steps we are taking. You find the total revenue. What's total revenue? Total revenue is price times what? Times quantity. In this case, you have different quantities, there's Q1 and Q2, and the price is given here. And they have said this Q you are seeing here is Q1 and Q2. That's how you could divide it. So that when you come to finding total revenue, the new price that you managed to find multiplied by what? The price that you have established for this one, where I said P is 1000 minus 0.5 Q1 minus 0.5 Q2. This is the price you could use. Then you multiply by Q1 to find the total revenue function 1. And when you multiply it like that, you can multiply again by Q2 to find the total revenue function 2. Now, these total revenue functions, Q for 1 and for 2, you can differentiate there. Both of them find marginal revenues. So you find marginal revenue 1 and marginal revenue 2. Then you set marginal 1 and equal to marginal 2. Oh, sorry, marginal revenue 1 equal to marginal costs. The marginal costs are here, they are derived from this total cost function by differentiating them. And then you can set them equal and solve the equation simultaneously. When you solve the equation simultaneously, for one, for example, for M1, it will just give you a function that has got two variables. So it will be called the reaction function. You also solve in the same way you find the reaction function for M2. Then solve the reaction functions simultaneously. Those are the steps. And you find the results Q1 and Q2. The optimal price is easy now because they're just saying in this same price, this is price equal to 1000 minus 0.5 times Q1 plus Q2. You already know Q1 and Q2 is 86. So it's 86 times 2, 172. Multiplied by 0.5, so it will be 1000 minus 0.5 times 172. Okay. So 172 multiplied by 0.5. This will give us 87.5, right? 1000 minus that. So this 1,000, from 1,000 to 1,000, 21, 2.5. This is the price. This is your optimal price. Very expensive, right? With the price was it's just 912.5. That's the price that could be charged on average. Utility companies' profits. If you want the profits now, can you find the profit functions of these, of each of these firms? You know how you find the profit functions from total revenue minus total cost. Those total revenue functions you found for each firm. Deduct the total cost of these functions. You find the profit function. In that profit function, where there is Q, substitute by the Q you are finding these Qs, the 86 that we found. And then you have the total profit for each firm. So that's a conversation. Find the total revenue for what's it, for facility 1 and for facility 2. Then deduct the costs. These are the costs. These are the you solve the equation and then plug in numbers. You will be able to find the profit. Right. All right. That's about question 1. It was a bit about cost.